So today we're going to be doing two-sum. And so in two-sum, we are given an array of integers sum and an integer target. We want to return indices of the two numbers such that they add up to target. So you're allowed to assume that each input would have exactly one solution and that you may not use the same element twice. You can return the answer in any order. So given these examples, so we have a list here and the target of 9, the answer is 0, 1 because 0 and 9 add up, or 0 and 7 add up to 9. And here we have 6, and we know that the indices 1 and 2, which is 2 plus 4, add up to 6. And same here. So here it says we can are we able to find a solution that's less than O of n squared time complexity, and I'll be giving you guys a solution that will be in O of n time. So let's go over to the whiteboard. So essentially our algorithm will be something along the lines of this. We're going to essentially iterate over the whole list. So let's say that nums is 11 to 15, 7. And we'll be keeping track of things using a dictionary. So let's say we have a dict here called my dict. And this dictionary will essentially keep track of keys and values, where the key will be the element, so element, and its value will be the indices. And so essentially how we're going to do this is, and oh sorry, of course we need to have a target here, so target equals 9. And so how we're going to do this is essentially the algorithm will be, we start here at the first index, and if the index, or sorry, if the target minus the index is in the dictionary here, then that means that we have our solution. For example, let's say we're here, right? And so 9 minus 11, that equals -2. Is -2 in my dict? No, so we're going to append 11 to the dict, and then the key will be 11, and then the value will be the index it's at, so 0. Next, we're going to iterate over the next thing, so we're going to be here. So is 9 minus 2, which equals 7, inside of this dictionary? It is not, so we will be adding 2, and then the value will be, or the key will be, or the value will be 1. Next, we iterate to 15. 9 minus 15 equals -6. Is that in this dictionary? No, so we append 15 and then 2. Lastly, we get to 7, and then at 7, we do 9 minus 7 equals 2. Is 2 inside of my dict? And as we can see, it is right here. So we can now essentially take the index of 2, so we take 1, and we take the index of 7 here, so that will be 3, and so this should return 2, 3, and that would be the solution. And so essentially the intuition behind this is that you can go over this in a one-pass solution because you kind of keep track of every answer, and if that answer is not readily available. So for example, let's say 2 is supposed to be part of the answer, right? It's okay if we don't deduce that instantly, because later on, once we reach 7, then it'll be clear that 7 plus 2 reach 9, which is our target. And so that's kind of how you do things for this problem. So let's get into the coding implementation of this. So like I said, we're going to be needing a dictionary. So myDict equals this, and we'll be iterating over the nums. So for I, j in enumerate nums, what this will do is basically give us, I believe, index and value. So we can print this to double check. Print ij, and then let's just return an empty array. So yep, index and then value. So we can name this a little better actually. So ind val. And so what we want to do is at every iteration we want to take val, or sorry, let's just say x equals the target minus the current value, and then if x in the dictionary, so this is where we check if these two add up to the target, and so if it is, then we essentially return the current index and the index which is in the dictionary. So my dict of x. And the other case is if x is not in my dict, then we essentially append. So my dict of sorry, one second. My dict of val equals its index. And lastly, if, let's see, each input would have a solution, so I guess we don't need to catch the other case, but this should hopefully run. Yep, accepted, and then we submit. Boom. And that's it.